Owen Tang, and I will be your teacher for today. In this lecture, we will be going over the quadratic formula, what it is, and how to derive it. The quadratic formula serves as an equation to find solutions to the equation ax squared plus bx plus c equals 0. It goes as follows. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. However, at first glance, it is unclear how we will arrive at this equation, which is what this lecture will be covering. We will be going over three major topics today: solving the vertex form of quadratic equations, converting a quadratic equation from standard to vertex form, and finally combining the two to get the quadratic formula. Let us begin with our first topic, solving vertex form equations. Before we solve a vertex form equation, we must know what a vertex form equation is. A vertex form equation is an equation of the form y equals a times x minus h squared plus k, and is called vertex form because the vertex of the graph of the quadratic equation is at h, k. For example, in the image shown here, where y is equal to x minus 3 squared plus 2, the vertex is at 3, 2. The reason why we want to solve vertex form equations is because they are a transformation of the standard parabola y equals x squared, which makes solving them as easy as simply undoing the transformation, as we can see here. Solving a vertex form equation is simple algebraic manipulation where we simply perform operations one by one to eventually isolate x. You will notice this plus or minus sign here right after we eliminate the square from the equation. This is because we are solving the quadratic equation by taking the square root, which leads to two solutions, a positive one and a negative one, such as how in the equation x squared equals 9, there are two solutions, 3 and negative 3, because both 3 squared and negative 3 squared are 9. The plus or minus symbol, therefore, tells us there are two solutions, one where we add the square root, or the positive solution, and one where we subtract it, or the negative solution. Now that we know how to solve a vertex form equation, let us move on to converting to vertex form equations. There are two major forms of quadratic equations, the standard form and the vertex form. There is also the factored form, but for now, that is not important. Standard form quadratic equations are in the form y equals ax squared plus bx plus c, and they're very commonly seen when we're dealing with quadratic equations, such as when we're working with kinematics. However, they are harder to solve than vertex form equations. On the other hand, vertex form equations are in the form y equals a times x minus h squared plus k, and while they are easier to solve, since we just did it, they are also not as commonly seen. Therefore, it is desirable to change quadratic equations from a commonly seen form, standard form, to an easily solvable form, vertex form. The way we do this is by a technique called completing the square. We want to convert a quadratic expression of the form x squared plus bx plus c to the form x minus h squared plus k. The leading term has been dropped the leading term a, but as you will see later, this doesn't really matter. We can fix this very easily. The key insight is to notice that x plus h squared is equal to x squared plus 2hx plus h squared, which is shown by expanding the left-hand side. Therefore, we want to find the value of h such that b is equal to 2h, since our b is here, and it is the part of the 2h term on the right-hand side, for some y equals x squared plus bx plus c. But since b is equal to 2h, that implies that h is equal to b over 2. This substitution, if we substitute it, allows us to get an x plus h squared term. Therefore, we rewrite our equation x squared plus bx plus c as y equals x squared plus bx plus b squared over 4 plus c minus b squared over 4, which is the same because we both add and subtract b squared over 4. But namely, because b squared over 4 is equal to b over 2 squared, which is this h squared term, this entire left-hand part becomes x plus b over 2 squared, and we're left with this plus c minus b squared over 4. This is the process known as completing the square. Now we are ready to convert a standard quadratic equation into vertex form. Our first step is to factor out the leading coefficient, and look, we have a quadratic expression without a leading term. This means that we can complete the square like we just did to rewrite our equation, and this gives us the equation in vertex form. Although in here we do have to factor out this constant term in order to get the equation into actual vertex form, because we're not actually multiplying the constant term by a in vertex form, as you can see. Finally, we are now ready to put what we have learned together to get the quadratic formula. So far, we have a way to get the solution to a vertex form equation. X is equal to h plus or minus the square root of negative k over a, and a way to convert a standard form quadratic equation into a vertex form quadratic equation, where h is equal to negative b over 2a, or if you actually go back, notice that it's minus h, but since we have plus b over 2a, we have to flip it where a double negative makes a positive to get that plus b over 2a again. And k, since that's just a plus, is equal to c minus b squared over 4a. Therefore, to get the quadratic formula, we substitute our values of h, and k into our equation for x to get our quadratic formula. And most of the slide is actually just simplification, algebraic simplification, so our quadratic formula is easier to compute. But really, here, this is already quadratic formula. We already have both of our solutions. But yeah, as I said, after this simplification, we get our iconic quadratic formula, where x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Thank you so much for listening to my lecture. I would ask if you have any questions if this was actually face-to-face, but since this is a video, I can't really answer them, so you can save them for later. And just if you are curious, here is the complete derivation of the quadratic formula without being separated into the two sections, as we did in this lecture. Finally, as a bonus challenge, can you derive the quadratic formula without completing the square? I've left some hints for such a method on screen. Feel free to take a moment and read them, and perhaps try yourself to do the alternative derivation.